So these are the numbers I got when I put 1986 and 2000 in, and they were typed here on the calculator. Here's the 1986 one right there, and here's the 2000 one here, and then I did it a second time because I copied it. Okay, let's flip this. Let's flip the page over. Okay. They said here, what year was a person born whose life expectancy was 67 years? Now, it's the life expectancy is 67. So when you read that, Rebecca, is life expectancy the X or the Y in our data? It's the Y. So this is Y equals 67. I want you to write that down. Can you see that, Hunter? Y equals 67 here. So I'm going to write my equation down. 67 equals 0.3258. I don't know the year that they were born. And then I'm supposed to add the y-intercept, which is 570, and I forgot what it is. What is it? 570 point what? 363 or something? Well, I got to flip it over. 5363. So it should be 5363. I've already put the 67 in, right? I put the 67 here where the Y is.
Wouldn't that be a negative?
Why?
What the 570 is?
It's a yes, it's a negative. Sorry, that's my. I just copied it wrong. Thanks, Grant. This is supposed to be. Make sure you put a minus sign here, not a plus sign like I did, because you'll get it wrong. I think we had someone else getting life expectancies of what, like 600 years or something. Okay, so how do I solve this, Victor? Give me the first step. How am I going to solve this equation? I got to work backwards for x. Just like the beginning of the year. Okay, you shouldn't be stumped. This is like the very first thing we did at the beginning of the year.
You got to add.
Add what?
570.
Add 570 to both sides. I'm not saying the decimal because it's more work.
Yeah.
Was it 5363?
Yeah.
So let's add those there. I'm going to do that on my calculator.
Add that.
So 67 plus 570.5363.
636.
So I don't have enough space, so I'm going to, or I can write it right here first. 637.5363 equals, we didn't do anything to this, did we?
No.
These canceled out. So we get 0.3258x. Now I don't have enough room to finish the problem, so I'm going to come over here. Yep. 637.53. All these decimals are wearing me down. So then Victor said we should divide. Divide by what, Victor?
0.325.
Yeah, the number in front of x. Nothing's changed. We're doing this all year. We'll be doing this almost all the time. So when we do that, we'll get an x value here. I'll just highlight it first. So we get x. So what is this number? I've got this number here. I have to divide it by 0.3258. This is supposed to be 5. You guys, I got another writing thing. I got problems here with my writing today. This is an 8. I reversed them. Okay, can you stop talking? Thank you. Can you just do the question? Okay, and so what do we get? What year is that? 1956.8. What is that close to? 1957. It's 1956.8, so it's really 1957. This person must have been born in 1957 if they're expected to live 67 years. Just so you know, my parents were born in the 40s. So my parents have eclipsed 67 years. I know you care. So I want you to do the same thing on this problem here. This is the exact same work we just did. You're going to have to figure out some things. Before we do that, though, we need to read what it is. So if, let's see here. If, Grant, can you read what this one is about?
The table shows the hours of TV watched by 10 students and their scores on the math.
Okay, so the independent variable, is that X or Y? X, and the dependent?
Y.
Okay, which one's going to be X here? Hours. Which one's going to be dependent? Scores. Okay. I'm going to let you find the equation of the line of best fit. If you don't remember how to do it, you're going to have to go to the front of your notes and go through all the steps, but you're going to enter these datas in. X's get L1, Y's get L2. I'll come around, and if you're having trouble, and help you out. So do that right now.